Okay, so welcome back to this course, ISM 416, Natural Language Processing. So we are going to continue from where we stopped in our previous lecture. And in our previous lecture, we started explorative data analysis. And I told you that explorative data analysis is the most important part of our data science workflow because over 80% of our time performing data science is spent in trying to clean and understand patterns in our data. Okay, and all these things are made possible through explorative data analysis. So it's very important that you really understand this part of the course, as every other thing we are going to be doing is built on top of it. So from next week, we complete this part of explorative data analysis. Then we look at text classification using machine learning. We try to look at some machine learning algorithms like the naive Bayes and the support vector machine, which you used in ISM 415. Then after next week, we are going to start looking at use cases like sentiment analysis, topic modeling, and text generation. And all these things are going to be built based on the knowledge we've so far acquired through explorative data analysis. So it's very important that you really understand this part. If there is any single thing you don't understand here or in the previous sections that we've had, please do well to let me know, and I will be willing to help you understand all this to the best of my abilities. Okay, so let's get started. So in our previous lecture, we looked at how to clean our Amazon review corpus, right? So I've deleted the last two cells here so that we can better understand this. Okay, so we want to try to clean the product column. Okay, the names of the product. Remember, when we looked at the unique values in the product, we found out that we have 8 unique products here. So, but when we try to view the unique product, we observe something. Some of the products, at the end of the name, we have 3 comma after it. Okay, what this signifies is that some of these products have their name duplicated. Okay, so at the end of this name, you have another name which is the same as this. And of course, you know, duplicate values in our data is bad for analysis, so we have to clean them, right? So, and to do that, we make use of the split function. We use split function when we looked at handling text with Python, right? So, and of course, you know what split function does. It splits your data or your text or your string into 2, okay, based on the pattern you provide. Now we are going to split these product names, okay, the individual rows, based on the 3 comma here. Okay, now another thing you should also know is that every step we are going to take here, or every step we've taken so far in this part, can be replicated for any product you're working on. Okay, you can use the same exact code that we're using here now for as many projects as you're going to work on. The only thing you have to change is the variable names. All the concepts remains the same. So this is very important for you to know, right? So now we want to clean this thing out. Okay, so the first thing we want to do is we index the column that we are targeting, which is the name column. Okay, so we call the variable name for our data, which is review. Okay, sorry, which is review. Then we index the product name column. Okay, so for us to really split this across the many rows in our data, we make use of the apply function, the lambda function, and the split function. Okay, I've really explained the lambda function for you, and I believe you understand it by now. In case you say find it challenging, kind of, you do what to let me know as well. Okay, I also explained the apply function, so we're going to use all this here, so you really need to understand all these things. So we say dot apply. Okay, so dot apply, the next thing that's going to come in is the lambda function. Okay, lambda, what am I missing? Lambda. Okay, so lambda, then the x, now in this case x signifies the individual rows, so anything on the right hand side, that's after your delimiter, is going to be what we intend to execute. So in this case we intend to split our rows based on the three commas here. So we simply say x dot split. Okay, so what we want to split it across, we want to split it across the 3 comma here. And of course, you know what the split function does is simply split your text or your string into 2. That means giving you 2 answers, right? So but we're not interested in any other thing after the 3 comma. Okay, we're just interested in the first one. So what we simply do is we index it, and of course, you know, Python starts counting from 0. So the first, from here to the first comma here, is regarded as index 0. So we make use of the square bracket and put our 0 and execute. Okay, so this is it. We are not interested in anything outside after the last name here, so we simply assign it to review.name. Okay, review. Okay, all right, so we're good. We'll go ahead and execute this. So we finally clean the product now. Okay, we finally clean the product name. So we are going to move over to the most important part, which is the review.text. We try to identify, to look at how the review.text appears and how to better clean this. Okay, so to do that, we call our review, okay, which is our variable name. Then we locate the column, which is the review dot text. So I'm going to try not to rush you in this part, so I'm going to take it as slow as I can for you to really understand this. Remember, I told you, for any text analysis you are doing, you can replicate this method, okay, and you can really agree with me based on what you've done in your email corpus, right? So some of you applied some of the techniques you've seen so far to cleaning your email corpus, and you're going to continue after this lecture. Okay, you get some of the knowledge as well and try to apply on the email corpus to further clean it. All right, so now we can index out the first. Okay, we can say we want to view the first row to the 40th row. Okay, so we can do it like this. Of course, what happened? Okay, let's see the error message. Review.text, isn't that the name? Oh, reviews, sorry. Okay, so if we want to see the first uh, 40 rows in this column, we can slice it. Of course, we did slicing now, so you guys are familiar with this process. So what I'm going to say, let's see if we can say from 35 to 40. Okay, okay, so when we do 35 to 40, we can see we have the index here and the text. Okay, so but I want to really list them in a way that is uh, easy for us to look at. Okay, now this is optional. You can decide to stop here, or you can decide to uh, go with me further. So what I'm going to do is I'm going to enumerate this. Okay, using the enumerate function. Okay, so this returns the enumerate object. So for us to view now, of course, when we slice this, we had two results, the index and the text. So we can write a for loop to print them out by simply saying for, since we have two results, the index and the text. Okay, so for index and text, in this enumerate, okay, we want to print, like I said, this is optional. Okay, this is not really data cleaning. We're just trying to see, to have a better view of our data, so we'll see what we're working with. So we can say print index comma text. So you can see, but this is not really what I want. Okay, I want it to be, I don't even want it to start from 0. Okay, so I want to just make it look interesting and tidy. So I can say review. Okay, so I'm going to use the print format. There are many ways to do this. You already agree with me. Okay, so this is my way of trying to do it. So dot format. So we've used the print format for a long time now, so you already know what I'm doing. So this index here now is for the first curly bracket, the text is for the second curly bracket. So I want this index now to be in the first line. So this \n indicates that this text now is going to be in the next line after the index. So by the time we do this, we have a better view, okay, of the product. So I don't, like I said, I don't want the review to start from 0. I want it to start from 1. So I'm going to do a +1 here. Okay. Alright. So this is how we got the other code. Okay. I was in a rush, I couldn't explain it to you, but now you understand. Okay. So but what I really want to show you here is that data is kind of dirty, if I'm going to use that word, because it has what we call contractions. Okay, so we're going to look at contraction later. Then it also has some special characters like the exclamation mark. It has numbers and what we call stop words, which I'm going to show you later. Now all these things could be important. In fact, they are important in human to human communication. But when it comes to machine learning and natural language processing, these things are really not as important as we think they are. Okay, in fact, they can cause a lot of problems for us in terms of our analysis. So we are going to remove them. Okay, so for that reason we are going to be performing some operations. The first one we're going to do is we try to expand these contractions. So contractions, okay, which you already know, are just, we can call it shorthand. So those things we use in order to reduce the speaking time or writing time of words. So instead of saying it is, we can say it's. Simple and short, right? So but for us not to fall into problems, we are going to expand it, and what that means in this context is expanding the contractions. Okay, then we also look at how to perform lowercase, right? So if we have my with the capital letter and my with the small letter, that's this my and this my, your machine, a normal human is going to identify it as the same thing, but a machine is going to look at them differently. Okay, and you know, in this area we really say that everything we are doing is case sensitive, right? So care has to be taken in everything we do. So for that reason we have to, for us to avoid having our machine looking at capital letter, looking at words that really means the same thing differently because they are just capitalized, is bad. So we are going to convert everything to lowercase. Okay, all right, so that's what we're going to do. We first of all look at how to expand the contractions. Secondly, we look at how to convert our text to lowercase. Then we look at how to remove the digits, okay, and all the special characters and the numbers containing digits. Then finally we look at how to remove punctuations. So it's going to be very interesting, so I'm going to take it slow, but I also have to be taking notes of my time. Alright, so let's get started, or let's continue. So the first one we're going to look at is expanding contraction. Like I told you, contractions are those words that we use in order to reduce the speaking or writing time of our normal words. Okay, so and I have a pretty good collection of different contractions. So I'm going to send you this notebook. I told you I'm going to send you in the last lecture, but since I haven't taught you, it wasn't really necessary sending you what I didn't teach you, okay? Just for me not to confuse you so much. Okay, so I'm going to copy this. I'm going to send you this notebook. Now, this is a pretty huge collection, but I don't think this is everything. So if you think there are some things that are not here, there are some contractions that are not here, please, you can do well to modify this. Okay, you can add as many as you want. So if you can see the contraction here, we have the contraction as the key. Remember, in dictionary we have keys and values. Okay, so the first one here is the key and the next one is the value. So the key are the different contractions and the values are the expanded contraction. Okay, so we are going to use this dictionary here to see how to clean the contraction in our review. Okay, so I'm going to go ahead and execute this. Like I said, you can add more. For instance, if you want to add more contraction, you put the contraction in a key first, put a full column and put the value, which is the expanded one. Okay, you guys are already used to using dictionary, so I shouldn't emphasize overemphasize. Alright, so for us to really identify these contractions in our um, review corpus, we need to convert it into a pattern. Okay, so a pattern that the machine will really understand, and to do that we make use of the compile function in regular expressions. Okay, I think we imported regular expressions. Give me a moment. Sorry. So we've imported regular expressions, so we're going to use it. We simply say re.compile. So if you want to get help on this, you just put the question mark. Like I told you, all these things are very simple. That's one major reason why I want to give you, I like to give you guys assignments at the end of each lecture, because these things, if you don't really practice them, it's easy to forget. Maybe as you just finish the lecture, you can easily forget as soon as possible. But when you play around with other data, try to figure out some unique problems and solve them, these things really become a part of you, and you understand that they are not really as hard as people think they are. Okay, so this compile function takes in majorly one parameter. Okay, this is like a flag to flag off errors and stuff. So, and what it does is it compiles a regular expression pattern and returns a pattern object. Okay, so if we have this now, we are interested in the contraction, so we compile the key values, that the contractions, into a regular expression pattern using the compile function. Okay, so let's look at it. I think it's going to be clear as we write the code. So we call our regular expressions. Okay, then we want to join these keys, okay, together, so as to make it easier for us to find them. So for us to do that, we use the this. Okay, then we use the dot join function. Dot join. Okay, then since we are just interested in the what is it called now, the key values, which are the contractions, okay, we simply write a code for to get the key values. And it's very easy to get the key values from your dictionary. You just call a variable name, then use dot keys. Let me show you. So you just call your variable name, which is contraction. Is it contraction or contractions? Let's see the variable name. Contractions. I'll just go ahead and copy this. Sometimes it's good to be lazy, but it's not really good to be lazy sometimes. Okay, so I'll go ahead and do this, paste it. Then if I do dot keys, okay, if I do dot keys, this will return the key values in my dictionary. Those are the what is it called now, the contractions. Okay, so that's what I'm interested in. I want to combine these key values, these contractions, into a regular expressions pattern for easy finding in our data. So I'm going to paste it inside the join. Okay, so when I execute this, I see all the contractions. Okay, so this will make it easier for our model to find these contractions in our text and expand them. So I don't really like this like this. Okay, I want it to be in, because of this could be an error for us. Okay, so I don't really want it. I want also have it in a tuple form. So for that reason, I'm going to specify a string, okay, of tuple, then I'm going to use the dot format to put all this value inside this tuple. Okay, it's very easy. Dot format. I'm sure you understand what I did. Okay, dot format. So we search for all these things, we arrange them in the way we want, right? But we don't want it because this can be a problem for us. So we simply put this inside a tuple for faster and easy and error-free search for us. So when we execute this, let's see what we get. Okay, so you can see this is now outside and every other thing we need is inside the tuple. So this is what we need, and we're going to call it contractions underscore RE. Now this is a variable name, so you can decide to call it ABCD or anything you want. Contractions. So I just like choosing a name that is easier for me to relate with. Okay, contraction dot regular expressions. So I'll just go ahead and execute this. Now the next thing I'm going to do is to write a function to expand this contraction. Okay, so these few days, okay, this few periods I've been thinking about this. Maybe I can write a kind of a library for you guys. Okay, so you can import it just like your pandas or your numpy instead of going through this many threads. But I later realized that it's very important that you know this. Okay, if you learn it the hard way, it's going to be hard for you to forget. Okay, if I just do it for you and give it to you, sometimes maybe one day you might lose the function or the library and you fall into problems. So by the time you learn this the hard way, it's going to be valuable. It's going to be a valuable knowledge for you. So we are going to write a function for expanding the contraction. So I'm going to say write a comment function for expanding contractions, and let me say this again. This step, especially even this part, okay, you can copy the code word for word and perform any test cleaning process. Okay, all you just need to do is to change the variable name. That's all. Okay, so you can use the same code for 1,000 projects relating to natural language processing, and you don't have to change anything except the variable name of your data. Okay, so having said that, let's continue. So the first function we are going to write is the function for expanding the contraction. Okay, so of course you know how to define a function, a regular function, not a lambda function. Now to do that we use the def keyword. So I'm going to call the function name expand underscore contraction. Okay, so this is going to take two parameters. The first one is the text, okay, which is going to be our individual rows in our review column, and the second one is going to be our dictionary. Okay, so we say contraction meanwhile there is a library for this contraction, but sometimes it doesn't install. Like I couldn't install it on my system. Okay, but if you want to really find it, the name is contractions. So you can try to do a pip install contractions on your Jupyter notebook and see, on your command line, and see if it's going to install, but we're just going to stick with this. I think this is okay for us, so I'm going to make it as simple as I can for you. So just paste it here. Alright, so this expand contraction taken into two parameters: the text, which are the individual reviews, and the dictionary for the contraction. So we specify our delimiter. Now, but this is not enough. We need to also define a function that is going to find and replace the matched object in this text. Okay, so what I mean by that is we define another function that will go through this function here, looks through the review. Anytime he finds anything relating to contraction, he will just replace it. So to do that, I'm going to define another function. I'll call it replace. Okay, replace. Okay, so replace is just going to take one argument, which is the matched object. Okay, so it's good. Remember, our compile returns a matched object for the pattern, right? So this thing is going to look for that matched object. And what is this going to return? It's going to return the group. Remember, some of these regular expression like functions like the search and the compile, they return a matched object. So for you to convert it to string, you need to use the group function, right? So that's what we're going to use to return it. We simply say return contraction contractions underscore dictionary. Okay, so and we're going to index the match.group. Sorry, match.group. So please don't cram this. If you can't, try to understand it, and you don't need to know the code word for word. You can just lift it anytime, but the only thing you just need to do is to understand that this is what this thing does. Okay, so that's all you need to know. Don't need to cram anything. So when we are done with this, we have to now return the result for the full function. Okay, so and how do we do it? We give me a moment. Okay, so to return the value for the main function, we make use of course, the return function first, the return keyword first. Okay, so what do we want to return? We want to return all the occasions where these things are matched. So we are going to use this replace function to replace all the contractions in this text. So we simply call this contraction regular expression, Ctrl C, Ctrl V. Then we use the sub function to substitute. Okay, we want to substitute all the contractions with the expanded one. So, and to do that is to use the replace first, replace, comma, then where do you want to replace it in the text. Okay, so this is all. We go ahead and execute this. So we've created our function. So meanwhile, much later, I'm going to show you how to maybe create your own kind of local library, just like pandas. So for instance, you can create a library for yourself using this function or any other function of your choice. So I'm going to show you what we are going to use to do that. Okay, we are going to look at pickling, especially when we want to deploy our NLP solution. So we need to convert our algorithms into a library kind of stuff. So we are done building our function. The next thing we want to do is to really apply the function by expanding the contraction. So I'm going to write a comment expanding the contraction. Okay, so we want to expand the contraction in the review column, right? So to do that, we have to index the review.text column, right? Reviews dot text. Okay, so then we make use of the apply function, right? Because we are looking at row by row now, we cannot just use the function directly. So we make use of the apply function. Okay, we want to apply using the lambda. You can see how important the lambda function and the apply function is. S signifies the row, please don't forget that. And what we simply want to do is to expand. We use the function that we just created. So just go ahead and copy this. Expand all the contractions in X in all the rows. So as easy as that. Simple. So if we do this, let's see. Hopefully we don't get any errors. Okay, so I have to pause the video. What is done? Okay, so we have no error, so it really means everything has been expanded, but we can't really see that now. So we just go ahead and assign it to the original variable. So we just put equal sign here on the left hand side, paste. So the result will be stored in this, which will be okay, so we can go up and try to rerun the other code, right? So you can see this one has contraction. Okay, I can't really see any other one, but you can search. So I'm going to run this to see whether really this was expanded. So okay, so you can see it has now been expanded to it is. So you can copy the same code and use it on your email corpus. Okay, exact same code. You don't have to change. What do you really have to change there? So the only thing you have to change if you want to replicate this on your email corpus is just your variable name. So I don't know what you called yours. Okay, so in case it is email, your email, then you, of course, the one you are going to be looking at now is the body of your mail. Okay, so here can be your body. I don't know what the column name is. I can't remember. Okay, but if you just look at it and change it, execute the same method, everything will be expanded. Alright, so now moving on, like I told you, we look at expanding contraction, which we just did. The next one we're going to look at is to convert to lowercase. Okay, now let's look at this also. How would it be, or how will it feel if we can just identify two things that are the same thing differently because they are just capitalized differently? for instance, my name is Charles, right? So does it mean in if you provide Charles to this machine now, a machine learning model, provide Charles with a capital C and Charles with a small letter c, the machine is going to identify the two names as different things entirely. So, and these are problems that we have to solve while doing analysis. Okay, to solve this problem, we try to convert everything to lowercase. Okay, now, yeah, so let's do that. So sometimes there can be implications. Okay, I'm going to show you on those occasions. Okay, when we start doing sentiment analysis and others, but it's very important to convert everything to lowercase. So let's do that now. I'm going to write a comment, lowercase the reviews. Now for some of you, if you've had any problems with the previous lecture, please don't be shy to let me know. Then if you've lost any of your notebooks, maybe any of your Jupyter notebooks from my previous lecture, you can send me a message and I will send you some of my notebooks. That's the notebook I'm using for my lectures. Okay, so alright, remember the primary idea of this course is not just for exams. Okay, if you really study and follow the course, okay, there's no way you won't really pass with an A in this course. But if you don't really study and if you don't do your assignments, well, the rest is history, right? So let's convert everything to lowercase. To do that, we call our variable name, which is review. Okay, so and the target variable we are looking at is the review.text reviews. Okay, I keep forgetting the x there. Dot text, right? So and we want to, of course, you can guess the next step is to use the apply function and use the lambda function. Lambda function, the S signifies the rows, and what we want to return, we want to return the rows in a lowercase, so we simply say s dot lower. So these things are just like spoken languages, just easy to do. So when you're done with this is all we need to convert our full column into lowercase. So we just go ahead and execute this. Hopefully you don't have errors. So you can see everything is in lowercase, which is what we want. So I'm going to call this, I don't really want to assign it to this thing anymore. I want to call it cleaned in case there is anything we missed while doing some of this cleaning. We can just go back to it and make adjustments. So I'm going to create a new column called cleaned. Okay, so I'm going to call the variable name review. So as you're going through this lecture, be picturing your email corpus and try to figure out some of the things I use here that you're going to use to better clean your data. Okay, so I want to use cleaned. So this is it. I'll go ahead and execute this. So if I do my review.head now, review.head, Okay, so you can see that we have a new column for clean data, so you can compare both of them and see that this is really cool. So the next thing we're going to do is to uh, write a function, a code to remove the digits, okay, and the words that are containing digits, because you can see 8 here is usually really meaningless in this context. So we're going to remove all the numbers and the words that are containing numbers. So to do that, we first of all call our, now we're going to be working with the clean data now, so we index it first, review. Hope this video is recording. Okay, good. Now, so call the review, index it, which is the clean data, cleaned. Okay, so you can guess the next method is to use the apply function. Apply function, and you can guess my next move, very predictable, to use the lambda function. And of course the next move is to use x as it's going to signify each row. Now the interesting part is going to be what is going to be returned. Now what we want to do is we want to iterate through all the rows and replace everything that is containing digits or words that are containing digits. We replace it with an empty string, and to do that we have to use the substitute function in regular expressions. So to write the pattern for it, you simply use re.sub. Okay, so you can get help on this, so I'm not going to, since you already know this, you all are pros now in this area. So I'm going to write the pattern for getting the words that are having digits and just digits. So first of all, we use the \w. You already know what this is used for. Give me a moment. What is happening? What is this? Okay, so if you don't know what this is, you really have to go back to your regular expressions and see. So then I want to do a greasy search of this. Then I want to match all the digits, then followed by all the characters, whether alphanumeric or just alphabet. So now this is the pattern for matching the words that are having numbers and just digits. So and what do I want to replace it with? I want to replace it with an empty string in my rows. So this is everything I need. So I'll go ahead and execute this. Hopefully it works. So let's pause this. Okay, so you can see it worked. The 8 here, you can see it's nowhere to be found here. So which is, you can see, but we notice something, there is a space here where the 8 is supposed to be, which is another problem we are going to fix. But first we simply assign this to our we assign it to our variable as updates. So you normally do updates. So we'll do that. The next thing we want to do is to remove punctuations. Okay, so this part I'm going to take it slow because it might seem a little bit complex, but it's not. So first of all, I want to remember we imported the string library, okay, which is used for handling strings. And in the string library, there is what we call punctuations, which account for the different punctuations that can occur in strings. Okay, to do that, we simply call the library name, which is string. Okay, then we use the punctuation function to list the punctuations. Punctuation. Yeah, I think this is it. So you can see these are the different punctuations in the string library, but this is kind of useless because we cannot really identify patterns in our text using this thing alone. So for us to smoothen this in such a way that we make it useful for us, we make use of the escape function. So you are going to see how the escape function smoothen this thing for us into usable form. So I'm going to use the escape function from the regular expression library to re.escape. All these things, I will keep repeating it. You can still copy the same code and execute anywhere. The only thing you have to do is to make use of the change the variable name. So I've used this code multiple times in many projects, and I will keep using them. So, but I just have to be updating them based on the new, because as time goes on, easier way of doing things will emerge. So I'll go ahead and run this. So you can see how the escape function has been able to structure this very well for us. So we are going to use this to remove all the punctuations in our clean data. So first we index it, review, we index the clean data. Okay, then of course you can guess my next move to use the apply function, and the lambda function. Why do I keep missing the b there? So x now signifies the row. Okay, then we use re.sub to replace all these things with an empty string. So anytime any of these things appears in our text, we simply replace it with an empty string, just like this. So yeah, that is it. So re.sub. So what do we want to substitute? We want to substitute everything here. So we'll just go ahead and copy this, paste it here, Ctrl V. So we want to replace everything here with an empty string in our row. So go ahead and run this and see. So you can see there is no comma here or anything, right? So that's it. So let's continue. Give me a moment. Okay, so we can see it actually worked. Did it? No, it didn't work. Okay, so alright, so we can enclose this result in a list first, then try to replace the pattern with a string. I think that will make it work. So we open a string, put a list, then put a curly bracket so that we can use the format function. So then we use the dot format. Okay, so we'll do this. Let's execute and see if it works now. Oh, we are having error. So this is supposed, you know what, let's start this again. So I'm going to get rid of this. So first I will, of course you already know, you understand what this is, right? So you understand up to this point. So I'll index this claim data again, review claimed. Okay, so the next thing I have to do is to use the apply function. Okay, so then the next one is the lambda function. Okay, with x signifying the rows. Then I have to use the sub function just like we used here. So sub function re.sub, sub. Okay, then what's going to come next is we need to enclose all these things in a list form. Then anytime these patterns are matched, we replace it with an empty string. So to do that, we open a list. Then since we are using the print format function, we use the curly brace. Then we say the dot format. Okay, so what do we want to format? This thing here. So Ctrl C, paste it inside it. Ctrl V. So anytime these patterns are matched in our text, we want to replace it with an empty string. Okay, and they are going to be inside this rows, which is x. So let's execute this and see if it works now. So it should work this time. Now we're running out of time. Okay, I think it worked. Yeah, it does work. It did work. So to avoid wasting time, we simply assign this to our variable. We update our variable, which is a clean variable, Ctrl V. So we'll go ahead and execute this again. So let's look at how much time we have left. Alright, we have less than 5, 6 minutes or 7 minutes. So next thing we're going to do is to remove, okay, we've removed the punctuations. So the next thing we want to do is to remove extra space. Remember when we remove the digits, it created an extra space, right? So we want to remove that now. To do that, we still make use of our cleaned column. So Ctrl V. Then we still make use of our apply function. Then followed by the lambda. Now we're still going to use the sub function for it. Of course, you know how to identify white space, empty space in a string, right? We did that when we looked at regular expressions. So simply say re.sub. That's sub. So what do I want to sub? I want to sub any white space occurring more than one time. Okay, any white space. Then I want to replace it with an empty space. Okay, so that it will match with the other string values in our row. So go ahead and execute this. So if you want to see whether this is really what you are supposed to do, um, let's try an example. Let's quickly try an example. I know this is going to take time, but at least it will make you understand this thing better. So let's try to say x is equal to, we'll give a space 1, 2, 3, 4, 5. Then we'll say Obi is a boy, for instance. So if we paste this function here, Control V, and try to, since we've defined x here, want to see what this is going to return, we can execute this and see. So you can see it cleans the white space for us. Okay, so this is, let's see if when we close this, what we'll get. So you see, when we close it, everything joined together. That's the reason why we are giving a space here on the other part. So you get the concept now. So some of you might want to ask why since we are cleaning an extra space, why are we not using empty string for it instead of a closed string? So the reason is, if we use a closed one, it's going to join all those things together, and we don't want it. So this is the right one to do. We simply copy this and update our cleaned column. Okay, I hope you guys understand this. So we go ahead and do it. If you still have any challenges understanding any of this, please do what to let me know, please and please. Alright, so now we can get we can print. I don't want to write this from scratch again because I don't want to waste so much time again. I'm going to copy this. Okay, so let's take a look at our data again. Control V. So now, what am I going to change? This is going to be cleaned now, not the text. Okay, so when I execute this, so you can see most of all those things are now gone. The comma, the punctuations, the numbers, the white space, and or they are all gone. So which is good. Now we are entering the next section. Let me see how much time we have. Oh, we don't have so much time. So we don't have any more time. So we're going to end here for this lecture, as the next line of code I wanted to add is going to be a bit, I won't use the word complex, okay, but it will really take our time a bit. So I want you guys to really go through this one over and over, try to apply similar technique on your email covers, and let's see what you arrive at. So we're going to end here for this lecture. I'll see you again next week. Until then, enjoy natural language processing, and don't forget to stay safe. Bye. Okay, please hold on a minute. I just realized that a few minutes is not going to kill us, so we are going to sacrifice a few more minutes to cover up this one line of code. Okay, these are things we already know, right? So the next part is going to be in 3 major forms. That's this next session now we're about to enter. Okay, although we are going to complete the remaining 2 in our next lecture, so as to reduce the amount of time we spend. So this next section is going to be in 3 forms. First thing we're going to do is to remove all the stop words. So what we mean by stop words are all these things like this, is, which are the and stuff. So in our normal human-to-human communication, this could mean a lot, but in machine aspects, this doesn't really add anything to the model. So we have to remove them so as to compress our data into the most important words. Okay, so that's what we're going to do now. We want to remove all the stop words, then we lemmatize all the words. Of course, you know what lemmatization is. We looked at NLP task, that's converting words into their root words, right? So then finally we look at how to create a document term matrix. So I'm not going to tell you that one now. We're going to look at that in our next lecture. So what I want to do now is to do lemmatization and stop word removal. So I hope we'll just finish it in a few minutes. Okay, so the reason I changed my mind is because I want to see how your email corpus is going to reduce by the time you apply this technique. Okay, stop word remover. Okay, so now to do that, I'm going to index my clean data. Remember, we are still working with our clean data, so I'm going to just copy this, Control C, paste it. Then of course I use the apply function. Please take note of this. I'm going to take it one step at a time. I'm going to, because this is very important. Okay, so what comes next is going to be our lambda function as usual. Then x signifies the rows. Then the next thing that's going to come is we want to convert what is going to be there to string. So I'm going to show you. We use .join. I'm going to show you what is going to be there, what we are converting to string. So now, how do you get the lemma from a token? We did that in NLP task, right? So it's very simple. You call your token, then you use the lemma underscore function. Please don't forget all these things. These are very key things for us. The lemma. So this will extract all the root words from all the words we have. So tokens or lemma. So but we want to do for all the tokens or lemma in our text. Okay, let me just show you, then I'll explain it. So token.lemma for token in, remember, for us to really use all these tokens and lemma, we need to make use of spacey. Did we even import spacey? Let's go ahead and check. No, we didn't. So we are going to import spacey. Okay. So we need to import spacey before we do all these things. So let me add the cell. Okay, so to import spacey, we use the import function, right? Import keyword, import spacey, simple. Okay, we use spacey for our NLP task, you guys remember. Then the next thing we want to do is to load our English model and call it NLP. Okay, so to do that, we call our spacey, then we use the load function for it. So how do we load the model? The model is en underscore core, that's English underscore core underscore web underscore statistical model sm. Okay, so execute this. Okay, so I've successfully imported the spacey and loaded the English language module. Now before you go further, please make sure you assign this to the clean the variable. Okay, so that because this line of code now is going to take a long while to execute for my system, because I'm using a very should I call it an old machine. It's not really old, boys. It took me about 20-25 minutes to execute this line of code. So you make sure you assign it to this variable so as to execute it once and for all, instead of having to execute only this part, then assigning it and executing it for almost an hour. Okay, so we continue. We apply the lambda function. Okay, else s here signifying the reviews. So we want to join everything here. Now forget about the join and focus on what is inside the parentheses. Then once you understand what is there, you can now deduce what we are trying to join. So now we want to get the lemma. Okay, so the lemma now is to lemmatize all the individual tokens. Remember, when you pass this string into spacey, okay, the English language module, it first tokenizes the string or the text, right, into tokens, and those tokens have different parsing and taggings. Like you can get the lemma by simply using the lemma underscore to get the root words of each individual tokens. So that's what we're saying. Token.lemma, that's the lemmas of the individual tokens. For token in, remember, for us to really use lemma, we first need to pass our text into this NLP module. So say NLP, and what is standard for our rows here is X, right? So for token in NLP X. Okay, so we are done with the lemmatization now. Okay, so we are converting everything here to their root words. Then to remove the stop word, we say all these things if they are not stop words. Okay, if not token is, if not token dot is underscore stop, just like we did dot is null. Okay, we are simply saying that now first of all you tokenize all the individual tokens, you lemmatize all the individual tokens in our X, which signifies all the individual rows, right? So provided that the tokens, that the individual words here are not stop words, and I told you what stop words are. That stop words are simply all these useless words with machines, like not, a, this, the, and is, all those many things. So those are the things we want to remove. And so once you're done with this, you go ahead and execute this. So me, I'm not going to execute this because it's going to take like 20-25 minutes. So I'm going to just, for you are going to execute this and wait for it to finish. So for me, I'm going to import the ones I've already executed and show you how it looks. What did I even call that? I think it's review.csv. So I'm going to say, I'll call the variable name D for sure. Sorry about that. So I'll call it D for short. Simply say pd.read underscore CSV. So I think I call that review. run it. So before it runs, I'm looking for the cleaned part of it. So I'll show you what I mean. And okay, so okay, now remember, you are not going to do this things with me because we've not already saved it. Me, I've already executed this, gotten my my updated data and saved it in my system so that I don't have to repeat this process again, which is a very time consuming process. So let me show you how the clean data now looks by the time you lematize and remove all the stop words. Okay, so you can see all the many rubbish that are there, like the D, E's, and many things. You cannot see them here anymore. So, and you, of course, you can observe that all these things here are in their root form. So you can't see running, run, and other things here. So they are in their root forms. I think that's basically it for now. So you can simply use the same process, the same exact code for your email corpus. So you can simply copy everything here, paste on your email corpus, exploratory analysis, and maybe change some things. So in the case of that one, this is going to be the body of your email. So this is it, and I believe we have made a lot of progress today, and I feel satisfied, okay, having shown you this last part. Alright, so now try to play around with all these things. Remember, practice makes perfect, right? And I'm always there in case if you need me, if you have questions on this, and maybe any other course you think I might be of use, okay, I might help you on. Just do well to let me know, and I'll do well to guide you the best way I can. Okay, so now stay safe, and remember, we are going to start our exams in July. So try to study hard, try to do your assignment. Remember, I'm not going to give you anything outside what we've done in class and what you've done in your assignments. So if you have been doing your assignments, there's no way you won't pass the exam in flying colors. Okay, so that's basically it. So stay safe, and I'll see you next week, and we'll also talk on the group. So until then, enjoy natural language processing for real this time. Bye.